Dear students and participants of the course on railway engineering, today we are going to continue our discussion on turnouts and points and crossings. In the previous lecture, we started discussing about the turnouts. We talked about the components. We also talked about the various terminologies which are used on the turnouts. And in combination of that, we discussed about the points and crossings. What are the various components which are provided on points or which are provided on crossings? What are tongue rails? What are switch rails? And how a turnout works. And continuation of that, today we will continue with our discussion related to tongue rails, switches and crossings. So, you will find there is some overlap with respect to the previous lecture and some of the other things we are going to discuss in more details. Now, this is a diagram for the points and crossings arrangements. So, here because you are looking at this particular points and switch operation from the crossing side. So, this is a crossing. So, if you are looking from the crossing side here, so that is a facing direction when you look towards this side. So, here when we are talking about the trailing and facing direction, that is a different thing, but let us look at the combinations. There are the lead rails being provided, there are heel blocks and assembly being provided at the heel, and then there is a tongue rail which is going up to this point, whereas the stock rail is a bit longer, and there is an angle which is being formed at this location, which we discussed as a switch angle. These tongue rails, they are moved using the stretcher bars, and when they are moved with using the stretcher bars, either a throw is going to be created at this location or the throw will be there at this location. If the throw is being formed here, that means now finally it is going to take a turn, but if the throw is being formed on this side, then maybe it is going straight. So, depending on how the arrangements are provided and which particular directional throw is being set, the movement of the train is going to happen. So, when we are discussing about the tongue rail, we said that it has a certain length and it can have a pointed edge towards the toe, or there may be possibility that it can be made blunt at that. So, this tongue rail is a tapered section and it is having a thickness at the toe same as the lead rail at the heel of the switch and 0.64 centimeter to 0.95 centimeter at the toe of the switch. So, when you are talking about this rail, it means when it is being provided at the heel, so whatever the thickness, normal section thickness is there, that normal section thickness will be there, but when it reaches the toe, then there it will be something like this. So, it is being changed from the width w to the width small w, and that is what we are saying. So, here it is on the heel, this will be on the toe. So, here if you see that this is being reduced in size. So, this is a small size here, but when you are going to the back side, then the thickness is equal to the normal rail section. It does not bear any load, it is being provided just to smoothen the directional movement. The half thickness of the rail should closely fit within the stock rail at the toe. So, this is the toe, and this rail section, the tongue rail, it should fit in very easily into the stock rail. You can see that here, this is a stock rail which is going on and then it becomes straight like this. So, this tongue rail is being provided the shape in this way that it just gets fit in with the stock rail. The tongue rail should be about 6 mm higher than the stock rail that we discussed previously, and it can be straight or it can be a curved. There are two types of tongue rails which are possible. So, in that case, In one you will find uh, that the tongue rail which are providing here. So, it has a curvilinear section, whereas in another case it has a straight profile, and that will make a difference in terms of the design of the turnout. So, when we will be taking up the design, at that point you will find out that difference. Now, straight tongue rails, they can be used for right hand as well as the left hand turnouts, and these straight tongue rails, they are usually used on 1 in 8.5 or 1 in 12 turnouts on Indian railways. I said that this is the way the crossing is being defined. Now, when if you talk in terms of say the gradients, then it is 1 in n. So, it is the same way here it is written as 1 in capital N, not n small n, and this capital N is abbreviated here as the number of crossing. Now, curved tongue rails, they are shaped as per the curvature of the track. So, whatever is the radius with which that turnout is being designed, or the movement from the straight section to the curved section and further is being designed. So, for that curvature only, this tongue rails are going to be curved. They are usually used on 1 in 16 and 1 in 20 turnouts. That means here we are talking about basically the higher category of turnouts, and these higher category of turnouts are usually used with high speed conditions, high density conditions of the traffic. These are also used in 1 in 8.5 and 1 in 12 turnouts on important roads. Otherwise, in the rest of the cases, 1 in 8.5, 1 in 12 turnouts are going to be there in most of the tracks. Wherever high speeds are there, we can go for 1 in 16, 1 in 20 turnouts. Now, length of the tongue rail. The length of the tongue rail, it varies with the gauge and the angle of switch. So, when we are talking about this angle of switch, this was the stock rail, and here there is a heel, and from this heel we are operating a tongue rail. So, this is the arrangement which we are talking here. So, this is a tongue rail. So, based on the gauge and based on the angle of switch, this is going to differ. That means we are talking about this angle of switch beta. So, if we are taking it smaller, so maybe now we are talking about a longer length or a smaller length here. Longer tongue rails will facilitate the smooth entry of the train to the switch due to smaller switch angles. So, it will be a case like this, and then if we are making it long, or the another case can be that you make it simple in this form. So, depending on that, so there is beta 1 and beta 2, where beta 2 is greater than beta 1. So, this beta 1 is what we are talking here, that is the longer tongue rails which are having the smaller switch angles. They are good for the smooth entry of the trains, and that is where if the case of the high speed tracks where the trains may be moving at a speed of 130, 160 kilometers per hour, and this type of system is better. The length is usually restricted in the station yards due to the space it occupies, because if you keep it increasing, it will require more length, and the number of turnouts being laid. So, in the case of a yard, it may happen that you have a main line, and from that main line number of turnouts are coming out in this form, and then they becomes the siding here. That means from the main line the train will come and it will be taken on this one or this one on this one, whichever is not occupied, and then final maintenance, washing or rearrangement of the wagons so as to form a train, everything will be done on those sidings. Length should be more than the rigid wheelbase of a four-wheeled bogie. So, whatever length we are talking here, that should be more than the wheelbase, rigid wheelbase. So, if we are talking about any of the wheelbase here, so that wheelbase may be in this form. So, it is smaller than the length of the tongue rail, and this reduces the possibility of the derailment due to the movement of a point. So, the theoretical length of the tongue rail, it is defined as L is equals to R into tangent of beta by 2, where beta is the switch angle, R is the radius of the curve, and L is the length of the tongue rail. Now, in the case of a broad gauge track, the length of the tongue rail is being defined for different types of turnouts, for the straight sections and for the curved sections. So, in the case of 1 in 8.5 straight, it is 4725. In the case of 1 in 12 straight, it is 6400, but if it is curved, it increases and it becomes 7730. When we talk about 1 in 16 curved, it further increases to 9750, and when we talk about 1 in 20 curved, it is 11150 mm. So, the length is continuously increasing, and accordingly the beta angle is going to be reduced. Then length of the switch rail. So, this length of the switch rail shall be longer than the length of the tongue rail by a minimum of 1.63 meters to 1.68 meters. Okay, so, with respect to the rail to which it is going to butt against. So, that particular rail we are talking here. So, with respect to that can also be termed as the stock rail. This takes care of the abrupt change in the alignment and discomfort it may cause while traversing it. So, any jump which will be happening here because of this 6 mm, it is not a big value, it is a 6 mm blunt edge. So, it changes here. So, all of that sort of a discomfort will be within that short range of 1.63 meters to 1.68 meters. The switches, we did talk about the switches before. Again we are discussing it here. There is a pair of stock rails made of medium manganese steel. So, anything like an A, B or C, D, they are the pair of stock rails which will be there. So, here I can mark them. So, this is A, B or C, D. The pair of tongue rails which are also known as switch rails, they are made of medium manganese steel PQ and RS. So, the tongue rails are being provided here inside. So, these are PQ or RS. So, they are smaller in size as compared to the stock rails. The tongue rails, they are machined to a very thin section, that means they are being manufactured in that form and then they have been brought to the site and being fixed. The tapered end of the tongue rail is called the toe and the thicker end is called the heel. So, the heel will be at this location which is having a thicker section of the tongue rail, and this is a toe where it is having a very thin section. The pair of heel blocks to hold the tongue rail at the standard clearance from the stock rail. So, there is a heel block provided at the heel here. Then slide shears would help in the movement of the tongue rail towards or away from the stock rail. So, that we have seen in a photograph in the previous lecture. Then stretcher bars which can be 2 or more. So, these stretcher bars are being shown here which holds the two tongue rails together at a specified distance and then also make them to move simultaneously leftwards or rightwards. Then gauge tie plate which is there, which is used to help in maintaining the gauge. So, this is another thing which we have already discussed. Now, there are two types of switches which are used. One is the stud switch, another one is the split switch. Now, in the case of a stud switch, there is no separate tongue rail is provided. The portion of the track moves from one side to another. So, whatever total portion is there, in this case there is not going to be the tongue rail. So, whole of the section has to move this way or that way, and it has inherent demerits, and looking at those inherent demerits, it is no more in use because all of the mechanical system, all of the total assembly has to be shifted, which is very heavy. In the case of split switch, it consists of the pair of the stock rails and tongue rails. That is what we have been talking so far in the previous lecture as well as before this slide. And there are two types of the split switches. One is the loose heel type, another one is the fixed heel type. That means at the heel point, whether it is being left loose or it is being fixed in position. So, that is what we are looking. Let us talk about the loose heel type of a switch. Now, this loose heel type, this is a tongue rail which finishes at the heel of the switch to enable movement of the free end of the tongue rail. So, at the heel of the switch, that means say if we are talking here, so there is a heel block at this location and a heel block here at this particular position. So, the tongue rail finishes at the heel of the switch to enable movement of the free end of the tongue rail. So, this is the free end of the tongue rail at the toe. The tongue rail is fastened to the stock rail using the fishing fit blocks and the 4 bolts. So, here in this case they are being fastened with respect to the stock rail which is provided here by using the bolts and the fishing plates. Fish bolts in the lead rail are tightened. So, that means here whatever lead rail is there, in that it is being tightened, whereas in the case of tongue rail they are loose capped. So, at this side they are left a bit loose, and this allows the free movement of the tongue rail. But again this has problems because of this loosening and continuous movement in the lateral direction with respect to the vibrations being induced and the movement of the trains, at that it causes inherent problems and the weakness is being induced in this particular section, and that is the reason that this needs not to be used. The another is a fixed type heel. So, that means again at the heel point which we are talking here, it is fixed at the heel. The fish plates and the bolts which are being used at these two locations, they are being tightened on the inner side as well as on the outer side. It used for the long tongue rails. The tongue rail does not end at the heel of the switch. The movement of the toe of the switch is made possible on account of flexibility of the tongue rail. So, this flexibility on the tongue rail is there, which is coming in form of the connection of the tongue rails with the help of the stretcher bars, and that is how it moves at the toe. So, this is the toe location and this one is the heel location. Now, there is a overriding switch. If you remember, we did talk about it, and at that time I said that we are going to discuss about it. Now, this overriding switch is what? Here the stock rail section at the toe remains full. So, this is a stock rail section. So, this is complete section being provided here. The tongue rail, it is planed to 6 mm thickness. So, here this is a tongue rail which is having a thickness of 6 mm, and it overrides the foot of the stock rail. So, it is being placed a bit higher with respect to the stock rail. So, it is going up. So, we did talk about it, this is again 6 mm. The tongue rail is kept 6 mm higher than the stock rail from the heel to the point where the planing starts. So, first of all the tongue rail will be having the same section. So, it may be having a section like this much thickness according to the top of rail head, and then finally it is going to be slowly and slowly, it will remain up to certain distance and then after that it will be reduced. So, this is what we are saying here. This arrangement is economical and good. The reasons being, it is stronger as the stock rail is not being cut. So, this rail remains in its original situation, that is why whatever the loads are coming on it through the wheel. So, this is a wheel at the top with flanges. So, it will be able to take the loads. Only tongue rail is to be manufactured. Now, because the stock rail section is not being deferred, only the tongue rail is being machined to a thickness of 6 mm towards the toe. So, only that has to be manufactured separately. And thin portion of the tongue rail, it is supported by the stock rail. So, by the end when it reaches towards the toe, it is being supported by the by this stock rail, and that is how it is being connected here. So, you can see here, so this is a flanged wheel. So, this is a flange being provided, this is a stock rail, here this is a tongue rail, So, this type of a section will be there and then it is being put in position here. So, there are different type of fastenings which will be used to do that. So, this is at the toe, but if you are talking about at a heel, then both of the sections they are of the same size. So, your stock rail as well as the tongue rail. So, this is a stock rail on this side and tongue rail on the left hand side. They both are of the same section. But when it comes to the toe, what we found is the stock rail remains of the same section and the toe rail has been trimmed, it has been planed to 6 mm thickness. Then another thing which we discussed, this tongue rail, it is being kept a bit higher as compared to the stock rail. So, this is 6 mm height and that 6 mm height will also come at this point. So, this again is a 6 mm height. Another type of a switch is a undercut switch. Now, if you see on the right hand side from the diagram, but you found that there is a stock rail here and a tongue rail on the other side of it, but both of the sections they have been cut. So, it is not the same that in the case of the previous one where you have the stock rail which was not being altered at all. So, it was the normal section which was used all along the length. So, in this arrangement the foot of the stock rail is cut to accommodate the tongue rail. So, it is being cut in such a manner that the tongue rail comes and just meets and butts against it. So, rest of the section if you just join them, so what you will find is that this will go in this form, but then because they have been cut there is a gap here. So, this brings in the weakness here. The tongue rail is planed to the thickness of 6 mm at the toe. So, here the thickness is 6 mm as being shown at the top. Both the rail sections are cut and therefore, this is a weak section and both the rail needs to be manufactured to the size so that they can be used at site so as to create this point and switch. So, it means previously we were talking about the manufacturing of the tongue rail only, but now this also has to be done, has to be brought to the site. So, this increases the work, this increases the cost. Now, crossing which we discussed previously also, which is a combination of wing rails, point rails, splice rails, and there we have different gaps between these types of rails. So, that crossing is a location where two crossing tracks, where two gauge faces they cross each other and permit the wheel flanges to move from one track to the another track. So, if a train is coming from this side straight, so it may go on this side or it may go on a straight. So, likewise the changes will be there. A gap is provided between the throat and the nose of the crossing. So, there is a throat here, there is a nose of the crossing and this is a gap which will be there over which the wheel flange guides or jumps. So, if it is coming from this side, then if it is coming like here from this side, so there is a gap here and finally it will be moving on this rail. So, there is a sort of a jumping at this location. To ensure that the wheel flange does not strike the nose, a check rail is provided on the gauge face of the another parallel rail. So, here a check rail is provided so that when this type of a jumping is happening, it should not happen that hits in. Say if it is the train is coming from this side and it is moving here, the wheel is moving here on this location and then it jumps. So, when it jumps here, it should remain on this size of the gauge face, not striking to the nose, otherwise there will be an issue. So, as to control that, the lateral movements which are possible, they are being controlled by the provision of a check rail here. So, this is an enlarged view of the same. So, we have these lead rails which are coming, they are making an angle of alpha which is a crossing angle. Here you can see that this is the point rail and the splice rails are there, and then if it has been taken forward to make a point, that would have been the theoretical nose of the crossing, but because it has been cut and is being made blunt here to a thickness of 6 mm. So, this shifts backwards and that is where it becomes a actual nose of crossing. There is a gap here. So, this gap is known as throat, because if you look on this direction it looks like that way, and this is a flangeway distance being provided between the wing rails and the lead rails, and the overall length of this crossing is going to be from the toe of the crossing to the heel of the crossing. Now, point rail, this is a machined manufactured, it is used to form the nose of the crossing. It ends at the nose as a thinner section, but so thin only that it may not break off under the movement of wheels. That means, we are not making it a pointed, because in that case if anything strikes here it will break down. So, we are making it almost up to that point that it is not going to break down. Therefore, the end is made blunt by cutting the rail to a thickness of 6 mm. Now, this toe of the blunt edge is known as actual nose of the crossing, whereas if it is going to the pointed condition, then it would have been defined as the theoretical nose of crossing. So, these actual nose of crossings and theoretical nose of crossings, which again and again we are discussing, they are again a part of the design of the turnout, and the distances are being taken either from actual nose of crossing or the theoretical nose of crossing. Then a splice rail, this is a rail which butts against the point rail. So, here you can see this is a point rail which is going up to the pointed condition, another rail which comes and that just meets the point rail. So, that is an splice rail. So, this is not going up to the nose, it is stopping before that. So, it is provided up to a distance behind the nose. It is also cut at the end to fit with the point rail. So, both the sections should fit in very clearly. That is the reason it has to be given a shape like this. Now, this V rail section so found, it has a depth of 6 mm at the nose and it runs out in 89 mm in the facing direction. So, if we talk about this, if it is being cut here at this point, but if otherwise it is running to this one. So, here the thickness is 6 mm, but otherwise it would have run for the 89 mm. This V section which we are talking, this is going to be running for 89 mm in this direction. The wing rails, these are the rails which are provided at this crossing. Again, they are 2 in number. So, you have the rail being provided here. So, this is a wing rail. These forms the throat or the crossing. So, this throat is being formed by the provision of this wing rail. After that, they diverge along the point rail and splice rail and they get flared at the end. This facilitates the entry and exit of the wheels with flanges in a smooth as well as the protected manner. The check rails, again 2 in numbers, guide the wheels flanges with the moving side wheels, protects the nose from hitting by the wheel. Now, let us look at the crossings. There are different type of crossings and they can be defined by different criteria. So, first is by the shape of the crossing, another manufacturing process, and the third based on the assembly of the crossing. In case of the shape of the crossing as we have discussed being formed by the point rail or the splice rail. So, there is an angle alpha here. This angle is the angle of crossing which was created. So, here we are talking with respect to that angle. It can be an acute angle crossing or it can be an obtuse angle crossing. But there may be a condition where the 2 tracks they cross each other like this. So, in that case there will be a square crossing which will also get formed. Now, if we talk about the manufacturing process, the built up crossing, from the name itself we can try to understand it is a crossing which is already being created, which being constructed or manufactured and then being placed and put at a particular location. Then cast steel crossing, that means we are talking about the type of material and the combination of the two, the combined rail built up and case cast crossings and the CMS crossings. In terms of assembly, it is a spring or movable wing crossing which can be there. Let us talk about the acute angle crossing, which is also defined as V crossing, and the another name which is given to that is a frog. So, in this crossing the intersecting gauge faces, they form the acute angle. So, this angle which is being formed here, this is an acute angle which is made by these gauge facings. It is formed due to the crossing of a right hand rail of one track. So, if you are coming from this direction, this is the right hand rail with the left hand rail of the another track. So, the another track, if you are coming, then this is another one which will be there. So, left hand and the right hand, sorry, this one will be the left and this one will be the right hand rail. So, that is how it is going to be created. Obtuse angle crossing. In the case of obtuse angle crossing, the intersecting gauge faces forms an obtuse angle. It is formed due to the crossing of right hand or left hand rail at a similar rail between two tracks. So, it is right and right, or it is a left and left combination which can be there, and this is also known as a diamond crossing. So, if we talk about say diamond crossing, so it can be something like this. So, here a diamond has got created. So, the way the rails are crossing each other, accordingly that will be defining that whether it is a left to left and a right to right, and the crossing will come. So, the obtuse angle crossing is going to be created. Square crossing as shown here, or I created the diagram previously also. There is a two tracks which are crossing each other at right angles. So, in this case you can see that right angles the things have been created. So, this is a right angle crossing which is coming here. The wing rails are provided so as to support that crossing at this point. Then based on the manufacturing process, we talked about the built up crossing. So, in this particular type of crossing, we have two wing rails V section consisting of a point and a splice rails. They are assembled using bolts and distance blocks. It is economical, easy to repair or replace because everything is being assembled, and if there is a requirement, so any of that part can be taken out. It becomes unserviceable if wear becomes more than 10 mm. So, in that case whole of the assembly has to be removed. There is a problem here in terms of the strength characteristics, it lacks rigidity, and the bolts they need to be checked periodically. So, if it means periodically you check, and there is a possibility periodic maintenance of those bolts is also going to be there in this type of a crossing. Cast steel crossing. This is a one piece crossing without use of bolts. It needs less maintenance because less fastenings are being used. So, obviously the maintenance is going to be reduced, and it has a rigidity, but the initial cost is high, and it has been made in one piece. That is the problem, that the repair or the replacement is not easy. Now, you have to take out the whole of that assembly which has been built as one piece. The third one is a combined rail and the cast crossing. The combined rail or the cast crossing, this is a built up and cast steel crossing combination. So, the previous to previous and the previous which we have discussed, that is a combination of those two. Here two legs of crossings at nose, they are made of the cast steel. The nose can fracture all of a sudden in this crossing, and that is the shortcoming of this particular type of a crossing. The another one is a CMS crossing. This is crossing which has been developed looking at the loads which are coming on the Indian railways. So, this type of crossing, it is suitable for heavy traffic tracks or tracks which are bearing heavy axle loads, or the suburban rail sections with electric tractions or high speed tracks. So, wherever either in terms of a speed, in terms of a load, or in terms of a repetitive nature of the similar roads which happens usually in the suburban rail sections. In those particular cases, it is better to go for CMS crossing. And because of the strength characteristics which are coming from the materials which have been used in this type of a crossing, it has a longer life, almost usually 4 times of the built up crossing. So, that is a very big advantage, and that advantage gets translated in the form of a requirement of maintenance, where it becomes economical as it is free of bolts and other components which tends to lose and requires the periodical checking and replacement. It has higher strength and higher resistance to the wear. Again, it is a property which is coming because of the material which has been used so as to manufacture this type of a crossing. These are mainly provided on a group 8 tracks, or the tracks where the traffic density is more than 20 GMT. If you remember, this value of 20 GMT is repeatedly being talked, less than and more than. These are the two cases which have been there. Then lastly is the spring or the movable crossing as far as the various types are concerned. In this type of crossing, one wing rail is movable and is held against the V of the crossing with a strong helical spring. So, the V of the crossing is being made and there is a wing rail which is coming like this. So, the another one will be in this form. So, the spring is being used at one side, at the another side it is being kept fixed. So, at this side it is being kept fixed. So, what is the advantage? Useful for high speed tracks on the main track and the slow traffic on the turnout. With the passage of the train, the movable wing rail snug with the crossing, and thus the wheel does not require to negotiate the gap at the crossing. So, what happens is, depending on in which particular direction this is moving. So, if the load comes on this one, then this will come nearer, and therefore, when it comes nearer it moves like this. So, the wheel which is coming from this direction is not required to traverse the gap. But in another case, if it is going in this form, then it will force the wing rail to go out, and because it is being provided with the spring, it will go out and it will easily move in this direction. The wheels and flanges, they will be moving in that direction. So, when the bogie passes on the turnout track, the movable wing is forced out by the wheels and the flanges, and the gap is formed over which the wheel passes. So, that is what I said. So, this is a sort of a arrangement. Here the helical spring is being provided. Initially this movable wing is touching the this is splice rail and the point rail combination at the crossing. So, it means when any train is coming from this direction, it is simply negotiating in this form, not a big gap is there which needs to be jumped. But when the train comes from this direction, then because of the pressure this will move. So, these were the various types of crossings which can be used. So, we close our discussion now. We discussed about the tongue rails, we discussed about the stock rails, their lengths, which are the components of the points and switches. We also talked about the various types of switches. We discussed about the crossings, their components and the various types which are used on Indian railways. With this we are closing it now. We will meet in the next lecture. Till then, thank you and bye.